Hi, my name is Keith Tenzer. I'm a solutions architect at Temporal Technologies. Today, I'm going to be talking about building durable, reliable, and scalable applications using workflows. But first, what is Temporal? So Temporal allows us to build and orchestrate applications as a workflow. By workflow, I mean a series of steps or actions, we call them activities, which are essentially function calls. Now, if we think about microservices or services in general, they're inherently unreliable. So when we're walking through or stepping through our workflow, orchestrating these services, we have to assume they're going to fail. And dealing with failure, of course, is not a trivial task. It adds a lot of complexity and time to whatever we're doing. And that's where Temporal comes in, by providing strong guarantees around durability and the primitives to implement state machines, timers, pollers, and retries, allowing you to focus on your application business logic, wrapping that in a workflow using the Temporal client, which allows you to communicate with the Temporal server through commands and queries, and you package that all up into a Temporal worker, which polls against the Temporal server. And it essentially waits for instruction or waits for tasks. When you submit a workflow to start against the Temporal server, it's going to orchestrate that against your Temporal workers. Next, let's talk about the value of building Temporal applications. So first and foremost is reliability. Your application always runs in a consistent state across all the services it interacts with, through any failures it encounters, and across time and the duration of that workflow. It also has advantages for developers around productivity. Because there is no DSL or domain-specific language, Temporal is just code. It's an SDK. So the same tooling frameworks that developers use to build their application is what they use to orchestrate it through Temporal as a workflow. And this allows developers to version, test, and deal with error handling seamlessly and easily, contributing greatly to their productivity and reducing complexity. Finally, Temporal really adds a lot of control around the workflow from a visibility perspective, allowing us to view and even replay our event history for a given workflow and interact or intervene with a workflow through signals and queries. Temporal also removes, if we think about it, the constraint of time itself. Workflows can run forever, which unlocks new and exciting ways to build our applications. So where is Temporal used? The short answer is pretty much everywhere and anywhere. So we see a lot of use cases around transactions, money movement, order management, business processes, for example, customer experience or compliance, and infrastructure and pipelines such as CI/CD, mass migration, data ML pipelines, and even around domain-specific platforms. Temporal, as we said, provides strong guarantees around durability and reliability and extracts away the complexities of doing so you don't have to deal with it. And it does so in a way without dictating your architecture. You have the freedom of choice. You can choose your own patterns, frameworks, what programming languages you'd like to create your Temporal applications in, the development environment you like to deploy them, and even the testing tools and frameworks. And Temporal is not something that just came out or has only been around for a few years. It's 15 years in the making. So the founders, Max and Samar, have really been working on this durable execution space and problem for a really long time, and trying and focusing on making that accessible to as many use cases as possible and around scalability. They've both worked through AWS and Azure, providing those capabilities and bringing them together essentially at Uber in the form of Cadence, which is sort of the precursor to Temporal itself. Today, Temporal is not only an open source project with a thriving community, but it also is a business, an organization that has a cloud service providing the capabilities of Temporal in a consumption model. So let's talk briefly about how Temporal runs. On the left side is your application, and the right side is the Temporal server. In this case, we have two pools of workers. We have workflow workers and activity workers. And so we're going to use the tctl, which is our CLI, to execute a workflow in the task queue hello world, which also can be done through the SDK. It's going to communicate with the Temporal server, which is going to start a workflow request, and it's going to be then picked up by our activity workers, which are polling against the Temporal server. And Temporal server really abstracts away all the complexities behind these strong guarantees, event history, matching, front end, persistence layer, as well as advanced visibility. So that's the ability to provide or tags or labels, if you will, key value pairs in your workflows so that you can query against them. For example, I could set foo equals bar in a workflow or a specific workflow run, and if I query for workflows that have foo equals bar, it'll return just those workflows. So all in all, Temporal really provides a simple elevated programming model, allows your developers to just write code using the Temporal SDK, operate Temporal through the Temporal server, and it abstracts away all the things that developers don't want to deal with, and gives all the capabilities that they really cherish around functions or activities, making them durable, consistent, fault tolerant, transparent, testable, and scalable. So how does this work in production? So there's essentially two ways to run Temporal applications in production. One, you can self-host a Temporal server using the open source. In this case, you have to obviously operate and operationalize it, but you can choose the platform of your liking to do so, or you can offload that to the Temporal cloud. You get a namespace as a service. Again, you still have the same worker either way with your application. You just point it, though, at a namespace, and off you go. And that's based on a consumption model, so there's no upfront costs. You pay when you start using it. So with that, I'd like to get into the demo, and I'd like to give a shout out to my colleague, Maya Ropers, who wrote this demo or created this demo. And I wanted to show you really two things that the demo exposes. One is how to interact with the workflows through an approval process that we have built into the demo, and the other one is how we deal with retries, and really show you kind of under the covers or behind the scenes what actually workflows look like and what you can see inside of Temporal. So with that said, we're going to jump right in. All right, as you can see here, I have this payment application. It's very simple. It takes a from account, to account, and a amount of money denoted in euros. And I have running here a Temporal worker, which is polling against the Temporal server in a task queue called money transfer. And I have that application I just showed you, which is also running here. It's also communicating with the Temporal server. You'll see in the approval process, and also it has to kick off workflows, so it has to interact with Temporal itself, the Temporal cloud. So let me go back and we'll start a payment. And I'm going to reward Mael for his awesome work in this demo. So I'm going to give him 1,500 euros. I'm going to execute that payment, and I'm just going to refresh my payments here, and you'll see this new payment, 1,500 euros, needs approval. You'll also see in the Temporal cloud over here that it started a workflow and it's running. So I'm going to go over here to approvals, and I'm going to approve this 1,500 euro transaction. Congratulations, Mael. You now have 1,500 euros. You did a great job. Thanks, buddy. All right, let's look at the workflow that actually completed here and step through things a little bit. So you can see here, it shows us the inputs from my account to my L's. There's a transaction ID created associated with this and the amount. And you can see here, it starts from the bottom to the top, the steps that are taken. Basically, every time any kind of state changed, it's persisted, and we have a record of it. And so Temporal kicks off the workflow itself. You can see the first thing we do is we upsert these search attributes. So those search attributes I mentioned, we're using those to set if a workflow needs approval, if it's been approved, if it's successful, if it's been rejected. So we're using those are basically key value pairs we're setting in advanced visibility. And then we're starting a timer. So you have basically 30 seconds from the point in time that the payment workflow starts to approve it. If you don't approve it in that time, the workflow gets rejected. If you do approve it, we cancel the timer, which you see here. And then it's going to start with withdrawing money, in this case $1,500 from my account and depositing it into my L's. And these are the activity tasks that you see here. And then finally, we are again updating the search attribute to set that this workflow was completed successfully. So let's go back and run this again. This time we're going to do a new payment, and I'm going to give money again to my L. I'm going to give him this time 500,000 euros. Don't get too excited though, because I'm not going to actually approve it. So it's going to get rejected. Sorry about that, Mael, but I don't have 500,000 euros for you. So as you can see here, it needs approval. And I'm going to go back and look here at the workflows. We can see it running. And you can see here, it's stuck at the timer started. So it's essentially going to wait for that timer to come back. And again, once it does, it's going to reject the workflow because it hasn't been approved. So at this point, I can refresh it since it's been 30 seconds. And you can see, in fact, the timer fired. And basically, it then sets the search attributes here that it was rejected and that it was not successful. So if we go back to, you can see the workflow completed, but if we go back to here, our payment application, we can see that, in fact, it was rejected. Now, I'd like to show you actually the code behind this, just to show you how easy this is and walk through that. So this is the workflow implementation here for transfer. You can see we're passing in the from account to account. There's a reference ID and, of course, the amount. We're setting a bool here is confirm that we use later, and then we're setting a signal handler. This allows us to signal the workflow. This is how we do the approval. So we can basically send a signal in saying, hey, I clicked a button, I approved it, and then we can take action based on that. Then we're going to just log that we got the request. Here's the logic. If it's more than 1,000 euros in this case, we set is confirmed to false because we want to verify if it's actually been approved. So we set this flag that needs approval. Then we set the timer for 30 seconds, and we wait if we get a signal or not. So if we get a signal in that 30 seconds, we set it to approved. If not, we set it to not approved. And then, of course, if it's confirmed, we withdraw the money from my account, deposit in my L's. We set it to success, and if not, reject it. And that's really it. It's really that simple. And of course, you can kind of visualize doing this. I mean, it's not super complicated, right? But it would be a lot of work to do this without Temporal and getting all the guarantees and everything else that you're getting. And so now let's move on to one of the other use cases that I wanted to show, which is around retries. So let's introduce into this workflow some errors. So what I'm going to do is the deposit. You can see here, these are the activities. Essentially, they're just logging information. It's not obviously really implemented any kind of payment transfers, as I mentioned, but we're going to throw an exception here. So I'm going to save this, and we're going to go back to our application, and we're going to create a new payment. Again, I'm going to give Mael some money. This time I'm only going to give him 100 euros. And if we remember the logic, it's not going to need approval. It's going to auto-approve essentially because it's less than 1,000. So I'm going to execute this. I'm going to refresh the payments here, and we can see 100, it's processing. So now if I go back to my workflows, and we should have a new workflow here, and you can see that it's pending activities. So one of the activities is failing. You can see this unexpected demo error. We can actually drill into that, and we can see it's already retried. It's going to keep retrying here, and so basically it's stuck. So what we can do now, we can fix this actually in real time, fortunately. That's just how easy this is. So we can, in this case, I'll comment out my error, but simulating fixing the problem, and we save it, and we're just going to go back here, and the next time it retries that activity, it's going to complete, and it's going to complete the deposit and the transaction. So we can just check here, refresh this, and you can see there are no longer pending activities. In fact, the workflow has completed, and if we go into the workflow here, we can also see that it was getting where it was hung up, and look at all the events that happened throughout the process of completing that transaction. And here we can see that our deposit was successful. So good job, Mael. You got yourself another 100 euros. All right, so that concludes the demo. At this point, I wanted to just show you how you can get started with the Temporal Cloud, which is the quickest, easiest way to get started. You just go to pages.temporal.io/cloud-request-access, basically get an account set up and a namespace, point your temporal workers there, and off you go. Now we mentioned also the open source. If you want to run this on your laptop or in a development environment, there's also something called Temporal Lite, which is really easy and simple. Can also get going really easily with that. So I wanted to just show you that real quick. So if you go to github.com/temporal.io, which is the organization for everything temporal, Temporal Lite, this is going to document basically how you get going, how you can build this and set up Temporal Lite in your own environment. It's basically a single binary written in Go. And I mentioned before, there's actually Temporal as an open source project. It's also under temporal.io/temporal. So you can follow along the progress here. And the beauty is the open source and Temporal Cloud, it's all using the same upstream Temporal. So the features, capabilities of Temporal itself are all the same. So you can, from your worker perspective, you can point it at Temporal Lite, switch it over to Temporal Cloud, back and forth. It all is very seamless and easy. That concludes this presentation. I just want to thank you. I hope it was worth your time, and I want to make myself available. If you have any questions, please feel free to reach out to me on Temporal's community Slack. Again, my name is Keith Tenzer, and thank you very much.